So somebody asked a question, which is a great question about when do I use trig substitution or when do I use other techniques? And so I'm going to scan through the chapter review, and I'm not going to do the problems fully. I'm just going to talk about what integration technique I would use. So those aren't integral problems. Not an integral problem. Here we go. So problem 10, not trig sub. It's a u substitution because when I look at problem 10, I can see u, and u prime. So I know that u substitution is going to work there. On problem 11, it is a trig substitution because there is nowhere else where this function's derivative shows up. There's no 8x or even just x where we can fix the constant. There's also no integration by parts that's going to be helpful here. And so this one is a trig sub because 1 minus 4x squared is Pythagorean theorem. We can draw our triangle, have here be 1, have here be 2x, and then this is square root of 1 minus 4x squared. And from there you can build out your trig substitution. Problem 13 is, well, we're told to use a particular trig sub. And again, it looks Pythagorean theorem-ish. So you have your triangle here where this is 2 and 3x, and then this is square root of 4 minus 9x squared. Just remember that the piece that's positive is going to be your c squared. And then I just call this b squared because c squared minus b squared equals a squared. And that's how I build out my triangles. On this one here, this one's not a trig sub because there's no x squared plus something or something minus x squared. This one would be an integration by parts, and you have to do it twice, each time picking u to equal the polynomial. So when you pick u to equal x squared, it's going to drop down to 2x, and then we'll drop down to a constant. Number 15, they tell us to do integration by parts, so no point really talking more about it. So in fact, it will be a cyclic integration by parts. 16 is not an integral, 17 is not an integral, 18 is not an integral, 19, 20. 21 is an integral right there. It doesn't look Pythagorean to me because you've got 2x squared plus 3x minus 2. This one would be a partial fraction decomposition. If you factor the bottom to be, let's see, 2x times x, and then 2, 1. So you can factor the bottom to be that, and then you split up your fraction to a over 2x minus 1 plus b over x plus 2 and go from there. You should be able to get natural log of p. Number 22, this one is definitely a trig substitution right there because you've got your c squared minus b squared. Let's see, 22 was trig sub, 23 I mean. This one right here, it's not a trig substitution problem. It's actually an integration by parts problem. You may not see it that way at first, but if you rewrite the integrand as x times cosecant, I guess your textbook writes like this, cosecant of x dx, cosecant squared of x, because 1 over sine is the same as cosecant. And then let's see, which one is cosecant? I know the derivative of tangent is secant squared, and so that means that if you have cotangent of x, the derivative of that, so d by dx, is negative cosecant squared of x. So you'll do integration by parts where your u is x and your dv is cosecant squared. Let's see, what other integrals are there? 24 is not an integral. 25 is going to be cyclic integration by parts again because you've got a exponential function and a trig function right there. And that looks like that's the whole review where all I did was talk about setting up the integral and what technique of integration I would use. If you want more in depth on any of those problems, please let me know and I'm happy to make a video for you.